Well, here we are near the end of the semester. Let's take a look at this review number 7. Hopefully this will give you some helpful hints. So with number 1 and 2, test for a linear correlation. You need to put the data in a list, like list 1. The pencil's not working. There we go. List 1 and list 2, life expectancy and obesity. So, sorry while I zoom down. So list 1 will stand for the X's and list 2 for the Y's. And hopefully you know from chapter 10 how to do that, test for a linear correlation. One thing I do want to point out is you need to write, instead of a bell-shaped curve, you can make a little chart like this. R's are always between -1 and 1. Look to table, excuse me a second. Look to table A6 for the critical values. One's negative and one's positive, and then you find out what R is. And if R lands over here, there's a positive linear correlation. If R lands over here, there's a negative correlation. And if it lands in the middle, there's no correlation, or at least no linear correlation. And also, when you find out that R from the calculator, you can find out what y equals ax plus b is. And then for this part right here, so when it says predict, that means use the equation y equals ax plus b and plug in an 8. So that says an 8% for obesity. Two things I want to point out. Sorry while I scroll again. One is obesity stands for y, so that means use y equals 8. The other thing I wanted to point out is, for example, right here with this 22, I just used the whole number 22, so for 8%, we used the number 8. Okay, so then that means that y is equal to an 8. You substitute that in, do a couple of steps of algebra, and you can find out what x equals. Number 2 is very similar, test for the linear correlation with the R. Then to a problem that's a little more challenging. So first of all, it's saying look at those with under 70 years life expectancy. So first thing I'll do is I'll go and highlight those that are under 70 years. So I'm probably not going to do the whole thing, but for life expectancy under 70 years. So that would be this one, this one, this one. Now because I read the whole question, at the end it said test the claim about how much meat they eat. So at the same time I'm going to highlight how much meat they eat per person. So this is less than 70, less than 70. After I have a few of them, I'll go over and highlight how much meat they eat. Here's another one under 70, and how much meat they eat. So anyway, you would do that all the way down the list. And then, for these red ones over here, you would go and put how much meat they eat into list 1. And then, for the other countries, take how much meat they eat, and then put that in list 2. And then you'll find the mean and standard deviation for each one of those lists. So back to the question, you would then organize the information like this. So those that are under 70, what's the sample size, what's the mean, and what's the standard deviation? For those that are living over 70 years on average, what's the sample size, what's the mean, and what's the standard deviation? And then the mean is about how much meat that they eat per person per year. And then the claim is that the two are the same. Be sure to write down H sub 1 and H sub O. And then when testing a claim about a mean, that means that it would be a t-test, so that's table A3, to look up the critical values. And then you can use the two sample t-test for the test statistic. And if it lands over here past this critical value, or over here past this critical value, then you did actually prove something, that the two groups are not the same. And this one is about proportion. And when it's about proportion, you would just need to know what's the sample size. So that would be from this information over here. Let me just copy that, paste it. Of course, it makes it too big, but anyway. So you just take that same information and then you go and count how many have more than 10% obesity. So that's going to be the X. So more than 10% obesity. So they're still highlighted where this group is going to be the red group. I guess I should have just put that in red. This is going to be the red group, and then how many have less than 10% obesity? So then you look over to their obesity and count them if it's less than 10. So right now I'm only looking at the red highlighted ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. 10. Anyway, so you count them, and whatever you get for that number, that goes right here. And then go to the other group that was not highlighted and count how many have more than 10% for their obesity, and that number goes right here. After that, you can do the p hat for each group. You divide those numbers. And then the claim says that they're the same, so the claim would be the proportion for group number 1 equals the proportion for group number 2. Again, write down the H1 and H sub O. And then because it's about proportions, you would use the Z table or table A2. And for the test statistic, you can use the 2 proportion Z test. And again, if it lands over here, or if it lands over here, then you actually did prove something. That would prove that the two groups are not the same. All right, then on to the contingency table. So what you need to do is, for life expectancy, find the median. So a life expectancy, I don't know what the median is, but I would say probably 70, which is probably the reason I used 70 in the previous question. I think that's probably it. So you have to use 70 as the cutoff. So then you say, well, those that are less than or equal to 70, those that are bigger than 70. So the equals needs to go on one of those two, and it doesn't really matter which. Now the idea is by using the median, that should divide the groups fairly evenly so that these two for less than or equal to 70, and these two squares for bigger than 70, it'll basically be half and half. So if there was a total of 30, I don't remember how many there are, but let's say there's a total of 30 countries, then it would divide them about 15 are here and about 15 are here. It doesn't have to be perfect, but it should be close to half and half. The magic of the eraser. All right, then you also have to divide it by obesity. So find the median for obesity. Suddenly my pen doesn't work. There it goes. And again, find the median. I don't remember what the number is, but you'd say less than or equal, and then bigger than or equal. Then what I would do is the less than 70 are the ones that are highlighted in red. And then let me just pretend I know that for obesity, the median is a 9. I don't know that it is, but you can find the median and put that number there. So then for this square right here, it needs to be, first of all, the ones that are highlighted in red, and also their obesity has to be less than or equal to 9. So then you would go back over here, look at all the ones that are highlighted in red, and then count them if their obesity is less than or equal to 9. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this one should have been highlighted in red, although that's not less than. So this one was supposed to be highlighted in red. Okay, so I think that was the number 10. So that would go right here where the smiley face was. Oh, I just wanted to get rid of the smiley face, but that's okay. So you put the number 10 right there, and then something like the number 5 will go right there. Then you go to the ones that are not highlighted in red. Let's say they were highlighted in lime green. And then do the same thing when their obesity is less than equal to 9 and when it's bigger than 9. And one important thing is when you add up, when you're done, and you've got all of these numbers, and I don't know what they are, but there's something like that. Then all 4 squares, so if there's 30 countries total, then all 4 of those squares would have to add up to 30. Again, I'm not sure exactly what the numbers are. I'm just trying to give you the basic guidelines of how to do these problems. And then for the last numerical problem, so now what we need to do is highlight, like in green, if their obesity is under 2, highlight in red if their obesity is between 2 and 20, and then highlight in this purple color if it's over 20. So first of all, with the green, that's going to be obesity under 2. So then I need to erase all of this other stuff, information, and did I get it all? And now highlight in green if the obesity is less than 2. So these guys, okay, I think that's all of them. Double check, all of them less than 2 are now highlighted in green. But notice that the question is about the amount of alcohol that they drink in that country. So now I'm going to go back with the green highlighter, and all the ones that are green, I'm going to highlight how much alcohol they drink. That is quarts per year, per person. All right, now all of the green ones are highlighted. Next, it was the red ones. So get my red highlighter, and those between 2 and 20. So between 2 and 20, and again, it's going to be about how much alcohol they drink. Between 2 and 20, yes, yes, and then highlight how much alcohol they drink. Between 2 and 20, between 2, yes, yes, and 2 more. And then you could just leave it like that because you then have the 3 groups, the green ones, the red ones, and the non-highlighted ones, or you could go back just for a sense of satisfaction, and I get to use my purple highlighter. Those with over 20 are in purple. This is also a good way to make sure that you've got them all categorized. So over 20, I'll call over 20, over 20, over 20, And then if you look at this list on the right, now everybody has been categorized in one of the three colors. Finally, the question is about their average alcohol consumption. So you go over here and all of the green ones, you put them in list number 1. And then all of the red ones, you put them in list number 2, etc. And then all of the purple ones, you put them in list number 3. Once you have all those numbers in the list, then you write down, here's the 3 groups. Those that are under 2 for obesity, those between 2 and 20 for obesity, and those over 20 for obesity. What's their sample size? What's the mean alcohol consumption? And of course, what's the standard deviation? So you find the mean and standard deviation for all of those. Then the claim is that all 3 means are the same. And with this one, you don't have to write down H sub O and H sub 1. Just the claim is good enough. And then this is going to be the Anova test, which is using the F distribution. It's right tail only. Then use table A5 to look up the critical value. And when you use the calculator, it will tell you degrees of freedom. It'll say degrees of freedom and then another degrees of freedom below that. So it's degrees of freedom 1 that shows up first, degrees of freedom 2 that shows up second. And then you can find the critical value in table A5. After that, on the calculator, use Anova, list 1, list 2, list 3, and then you'll get the test statistic. Okay, then a brief description of what was proved. So, for example, in this one, I would assume that you would get reject. They are not the same. And most likely, these people would have the highest alcohol consumption. So if a country is very, very poor, then most likely they're going to have very little obesity. So that would be most likely these countries. And if they can't afford food, then most likely they can't afford alcohol. Where the richer countries like Germany, the United States, Italy, France, they can afford a lot of food, there's more obesity, and then people can afford to buy more alcohol. You can also use the linear correlations. Life expectancy and obesity. There's probably a positive linear correlation, which means that as life expectancy goes up, obesity goes up. And on an individual basis, having a high obesity is probably not going to help that individual's life expectancy, but for a whole country, it's basically about money. If the country is rich enough that the people can afford a lot of food and many people become obese, then they can also probably afford good health care, being able to buy medication, etc., etc. So these are the type of explanations that should go at the end. All right, that's it. Good luck and have fun.